To create this shape, I look at it from the top view. I will apply the fillets in this area at the end of the work. So I look from the top and draw this bottom sketch. It will be a 70 by 40 millimeter rectangle, placing the origin inside this circle. So I enter the part module. On the top plane, I draw a circle with a diameter of 30 millimeters. And using the first rectangle type, corner rectangle, I draw a rectangle measuring 40 millimeters by 70 millimeters. This circle is located at a distance of 50 millimeters. And I place the center point of this line segment horizontally with my origin. Okay, I extrude the sketch by 20 millimeters. Without exiting the sketch right here, I go to the Features tab and select the Extruded Boss command. SolidWorks automatically detects which areas to extrude. So in this section, I extrude my shape by 20 millimeters using the blind condition. Now, to draw this part of the shape, I look from the top again and draw the sketch on this face to create the shape I see from above. A size of 30 millimeters and a thickness of 10 millimeters. I enter a sketch on this face, go normal to the face, and draw the sketch using the line command. I make these two equal to each other and apply a size of 30 millimeters. I set an offset distance of 10 millimeters for this section. I extrude the sketch I just drew on this face by 20 millimeters. So again, without exiting the sketch, I enter the Features tab and use the Extruded Boss command to add volume to the sketch by 20 millimeters. Next, according to the reference drawing, to create this slope, I'll draw a sketch on this face, a triangular sketch. And then I'll use an extruded cut to remove material by 10 millimeters. So I enter a sketch on this face and draw a triangular sketch. From this area to this point, then this point, and up to this point, measuring 20 millimeters. Well, a dimension isn't needed here because these points have become coincident. We'll discuss this in more detail later. 20 millimeters and another 20 millimeters. And using the Extruded Cut command, I remove material from the shape by 10 millimeters based on the sketch drawn here. Then, according to the reference drawing and the radius of 10 fillet, I apply a fillet to these corners. So from the Features tab, Fillet command, I define a fillet with a radius of 10 millimeters for this edge and this edge. This is how we design the shape. When we design a part in SolidWorks, very often the next stage is editing that part. In most cases, editing a part is actually more difficult than designing it from scratch. The more principled and careful we are during the initial design, the easier and less painful the editing process becomes later. Let's examine an editing example within this part. Let's assume that after designing this part, we need to change the thickness of this part from 10 millimeters to 12 millimeters. What should we do? We must go and find the feature that created this section, which is this feature. Since we want to edit the sketch, we can right-click on it and choose Edit Sketch, or from the pop-up here, select Edit Sketch. Or find the sketch in the Feature Manager tree and right-click to select Edit Sketch. We enter Sketch Editing Mode, go Normal 2, and change this value from 10 mm to 12 mm. As soon as I exit the sketch, the changes are applied. However, this extruded cut, since I set it to cut 10 mm, is now causing a problem. Imagine if you were working on a complex part. Small details like this could really cause issues. To fix this problem, I find the feature where I made this cut, which is this extruded cut right here. I edit the feature, and this time, instead of cutting 10 mm, I set the direction one end condition to up to vertex. And in this box, I can specify that the cut goes up to a desired point. For example, up to this point here. Now, if I click OK and edit the sketch again, this time, no matter how much I change the thickness, for example, if I change it to 14 mm, it still cuts up to the corner point. Let's go back to the extruded cut feature and edit it again. So we select up to vertex here. And in this section, we define the point up to which the sketch will be cut. Well, from this same section, this time I select up to surface. A surface means a face of the model, either flat or curved, or even a reference plane, and I can specify it here. For example, cut up to this surface or this one, which gives the same result. If I click OK, no matter how much I change the thickness, for example, even if I change it to 5 mm, it will still cut the shape up to the surface I specified. And again, in this same section, we've covered up to vertex, up to surface, and up to next. Up to next cuts the model up to the first face or boundary it encounters in the direction of the cut. In this case, the cut stops at this face, because if the sketch continues, it would end here. However, if I change the thickness to 13 mm, and go back to the extruded cut, since the sketch now extends to this point, the next condition is defined by this face. It starts from this face and cuts up to this one. So if I select up to next, it cuts up to here this time. So now we're familiar with up to next, up to vertex, and up to surface. For this example, I select up to surface and choose this face as the limit for the cut. Okay, I set the dimension back to 10 mm. And this time, we'll look at another key point together. The next point we want to look at is that I want this sketch, or the slope created by it, to always start from this face. Here, if I change the thickness to 12 mm, we can see that the slope now starts forming from this inner edge within the thickness. The reason is that when we drew this sketch, we set this dimension to be 20 mm. Well, when this dimension changes, while the 20 mm value stays the same, the slope naturally starts forming further inward. First, we need to remove this 20 mm dimension. Then, while creating the sketch, we can try selecting this point and this edge to apply a pierce relation. However, since the edge doesn't extend to that point and no intersection is detected, the relation won't be applied. In this case, it's better to select this face and the point, and then apply a coincident relation. No matter how this face changes, this point will update along with it. Again, in the same way, this coincident relation is applied to this line. Also, this coincident relation is applied to this line. For this reason, even without adding any dimensions, the sketch is fully defined, because all the triangle's points are constrained to different entities. So, if I make this point coincident with this face, no matter how I change the dimension right now, for example, to 13 millimeters, the shape will remain exactly as intended. So, you need to pay close attention to these small details when choosing your sketch, feature types, and conditions to avoid problems during later edits.